Pharmapal.
New skeletal flavonoids of Anastatica Hierochuntica. Welcome to our channel. Today, we're diving into the fascinating world of bioorganic chemistry, focusing on two remarkable compounds, anastatins A and B. These newly identified flavonoids exhibit potent hepatoprotective properties. In this video, we'll explore their structure, how they were discovered, and their potential applications in medicine. So, let's get started. In recent years, the search for natural compounds with therapeutic benefits has intensified. Among these, flavonoids have gained attention for their health-promoting properties. Anastatins A and B, isolated from A. Hierochuntica, are two such compounds that have shown significant promise in protecting liver cells from damage. But what exactly are flavonoids, and why are they important? Flavonoids are a group of plant metabolites known for their antioxidant effects. They play a crucial role in protecting cells from oxidative stress and inflammation. In our study, we focused on the structural elucidation of anastatins A and B, which could lead to new treatments for liver diseases. To uncover the secrets of anastatins A and B, we employed a variety of analytical techniques. 1. Isolation. The compounds were extracted from the A. Hierochuntica plant using organic solvents. 2. Characterization. Techniques such as NMR, nuclear magnetic resonance, IR, infrared spectroscopy, and MS, mass spectrometry, were used to determine their structures. For instance, the NMR spectra provided detailed information about the hydrogen and carbon environments in the molecules, helping us confirm their unique flavonose structures. By combining these methods, we not only identified the compounds but also elucidated their absolute stereostructures, which is crucial for understanding how they interact with biological systems. The results were quite exciting. Anastatin A was isolated as a yellow powder with a molecular formula of C21H14O7. Its unique features include positive optical rotation, indicating its chirality, characteristic absorption bands in the IR spectrum that suggest the presence of hydroxyl and carbonyl groups. Anastatin B exhibited similar properties, confirming that both compounds belong to the same flavonone family. Moreover, both compounds demonstrated significant protective effects against D-gallin-induced cytotoxicity in primary cultured mouse hepatocytes. This means they can help protect liver cells from damage caused by toxins. So, what does this all mean? The discovery of anastatins A and B opens up exciting possibilities for developing new hepatoprotective agents. Their ability to inhibit cell damage could lead to breakthroughs in treating liver diseases, which are a major health concern worldwide. Furthermore, the structural insights gained from our study can guide future research into modifying these compounds to enhance their efficacy. The potential applications extend beyond liver protection, as flavonoids are known for various health benefits, including anti-inflammatory and anti-cancer properties. Figure 1. Mass fragmentation pattern of anastatin A. First up, we have Figure 1, which illustrates the mass fragmentation pattern of anastatin A. What does this mean? Mass spectrometry is a technique used to determine the molecular weight and structure of compounds. In this figure, we see the molecular ion peak at M/C378, indicating the molecular formula of anastatin A is C21H14O7. Key peaks: 258, 100%. This peak is the most abundant and indicates a significant fragment. Other notable peaks include 230, 202, and 120, which provide insights into the compound's structure through fragmentation pathways. This figure helps us understand how anastatin A breaks down, revealing its structural components. Table 1. Inhibitory effects of extracts on D-gallin-induced cytotoxicity. Next, let's move on to Table 1, which summarizes the inhibitory effects of the MeOH extract and the ETOAC soluble fraction from A. Hierochuntica on D-gallin-induced cytotoxicity in primary cultured mouse hepatocytes. Understanding the data. Each value represents the mean percentage of inhibition, with statistical significance indicated by asterisks. For example, at 30 mg per milliliter, the MeOH extract shows an inhibition of 52.2%, while the ETOAC soluble fraction shows an impressive 80.9%. Why is this important? This table highlights the potential of these extracts in protecting liver cells from damage, suggesting they could be valuable in developing therapeutic agents. Table 2, 13C NMR data of anastatins A and B. Now, let's take a look at Table 2, which presents the 13C NMR data for anastatins A and B, along with their acetates. What is NMR? Nuclear magnetic resonance, NMR, spectroscopy is a powerful tool used to determine the structure of organic compounds. The table lists the chemical shifts for various carbon atoms in the molecules. Key observations. For anastatin A, the carbonate C2 shows a shift of 80.4, while for anastatin B, it's 80.8. This slight difference can indicate variations in the molecular environment of these compounds. Understanding these shifts allows chemists to deduce the structure and functional groups present in the compounds. Figure 2. Inhibitory effects of anastatins on cytotoxicity. Finally, we have Figure 2, which graphically represents the inhibitory effects of anastatins A and B on D-gallon-induced cytotoxicity. The graph clearly shows that both anastatin A and B exhibit significant protective effects, especially at higher concentrations. For instance, at 30 mm, anastatin B achieves an impressive 55% inhibition, outperforming many other flavonoids tested. Why this matters? This visual data reinforces the idea that anastatins could play a crucial role in liver protection, which is vital for developing new treatments for liver diseases. What are the key structural features of anastatin A and B that distinguish them from other flavonoids? Anastatin A and B are characterized by a unique benzofuran moiety at the 6 and 7 positions of the flavonone structure. This structural modification is confirmed through NMR and mass spectrometry (MS) analyses, which show distinct signals and fragmentation patterns that are not typically observed in other flavonones. How did the authors determine the absolute stereostructure of anastatin A? The absolute stereostructure of anastatin A was elucidated using a combination of techniques. Circular dichroism, CD, spectroscopy indicated the absolute configuration at the 2 position. Heteronuclear multiple bond connectivity, HMBC, experiments provided long-range correlations between protons and carbons, confirming the placement of the benzofuran moiety. Mass spectrometry revealed characteristic fragment ion peaks, further supporting the proposed structure. What were the observed biological activities of anastatins A and B in the context of hepatoprotection? Anastatins A and B exhibited significant hepatoprotective activities against D-gallon-induced cytotoxicity in primary cultured mouse hepatocytes. The study demonstrated that these compounds showed stronger protective effects compared to other flavonoids and the well-known hepatoprotective agent psilocybin. What analytical methods were employed to characterize the physical properties of anastatin A and B? The authors utilized several analytical techniques. Infrared, IR, spectroscopy to identify functional groups. Ultraviolet, UV, spectroscopy to determine absorption maxima indicative of flavonone structures. Nuclear magnetic resonance, NMR, spectroscopy for detailed structural analysis, including both 1H and 13C NMR. Electron impact mass spectrometry, EIMS, for molecular weight determination and fragmentation analysis. What implications do the findings of this study have for future research on flavonoids? The findings suggest that the unique structural features of anastatins A and B could lead to the discovery of new flavonoid derivatives with enhanced biological activities. This opens avenues for further research into the structure-activity relationship, SAR, of flavonoids and their potential therapeutic applications in liver diseases and other conditions. Thank you for watching, and see you in the next video.
Pharmapal.